Hey everybody. Today we're going to talk about the graphs of other trigonometric functions. We're going to split this into two parts. We're going to talk about tangent and cotangent today, and then for Thursday's lecture we will cover secant and cosecant. I know I threw a lot at you last week. I think it's important that we slow down a little bit, make sure we get all our questions answered, especially about our sine and cosine functions and how to graph them, do the problems from the book, and reach out with any questions. So let's start with tangent. Now the definition of tangent of x is the y-coordinate on the unit circle over the x-coordinate on the unit circle, or even if it's not a unit circle, the y over the radius and then x over the radius, and those cancel. Now the y-coordinate is the same thing as sine of x, and the x-coordinate is the same thing as cosine of x. So you can think of tangent of x as sine over cosine. And as we go through and talk about different values of different angles for tangent, we can sort of get an idea of what tangent looks like. So I have this table of values here, and we're just going to start with tangent of negative pi over 2. Now that's the same thing as thinking of sine of negative pi over 2 over cosine of negative pi over 2. Now, we haven't really talked a lot about negative angles. What a negative angle means when we're talking about the unit circle is normally we go this way around the unit circle, and those are positive angles. A negative angle just means I'm going in this direction. So negative pi over 2 is actually right here. And if we think about the point on the unit circle, this point right here is the point 0, negative 1. And so sine, which is the y value, would be negative 1. And cosine is actually 0. And we know that when we divide by 0, we are killing unicorns all over the world. And so this is actually undefined. And this is how I would put this in the table as undefined. So now we move on to negative pi over 3. So that's this angle here. It's the bigger angle because I'm dividing by a smaller number. And we can think of the reference angle, which is just positive pi over 3. We can think of the values there. Just the y-coordinates would be negative, and that's how we figure out the values here. So again, we're thinking of sine of negative pi over 3 over cosine of negative pi over 3, and sine of pi over 3. So I'm talking about the y-coordinate. So I'm higher than I am over to the right here, and in this case I'm actually lower because it's down here. And so this is going to be negative root 3 over 2, okay, over cosine. That's the 1/2. That's positive 1/2. And then the 1/2s actually cancel here, and so I get negative root 3. So this is negative root 3. And then we go on to negative pi over 4. So this is sine of negative pi over 4 over cosine of negative pi over 4. And that's the angle where both I am equidistant in the x and the y direction. That's that 45-degree angle. And so my sine is going to be negative because I'm in the fourth quadrant. So that's negative root 2 over 2. And then I have root 2 over 2. And anything divided by itself is 1. So this comes out with the negative sign. It comes out to negative 1. So tangent is negative 1 at that value. And the last one I'm going to do out here is tangent of pi over 6, negative pi over 6. We'll do 0 as well. But then the positive values here are going to be exactly the same as the negative counterparts, except now that we're in the first quadrant, both the y and the x coordinates will be positive, and so we'll get the same values, just positive instead of negative. So we have tangent of negative pi over 6. So that's sine of negative pi over 6 over cosine of negative pi over 6. And I am farther to the right than I am down here, and so sine is going to be the negative 1/2. Cosine is going to be positive root 3 over 2. The 2's cancel again here, but that leaves me with negative 1 over root 3, which I want to rationalize this denominator. So I'm going to multiply by root 3 over root 3, and we get negative root 3 over 3. Okay, so the final one is tangent of 0, and that's sine of 0 over cosine of 0, sine of 0 being 0 and cosine of 0 being 1, and so that gives me 0. Okay, and then like I said, since the reference angle for all of these fourth quadrant angles are the same, the only difference is going to be that my y coordinates are no longer going to be negative in the first quadrant. So this is going to come out to root 3 over 3. This will come out to positive 1. This comes out to root 3. And then at pi over 2, I'm going to have 1 over 0, which is still undefined. Okay? So if we go and look at the graph of this, if we graph all these points, okay, which I happen to have a graph right here, I had pi over 6 as my smallest value, so I'm actually gonna count up by pi over 6's. So we have pi over 6, and then 2 pi over 6 is pi over 3, and then 3 pi over 6 is pi over 2, and then 4 pi over 6 is 3 pi over 2, 2 pi over 3, 2 pi over 3, and then 5 pi over 6, and then 6 pi over 6, which is pi, and then 7 pi over 6, and then 8 pi over 6 is 4 pi over 3. All right, and we can fill this in going in the negative direction as well. And the reason I left a space here is because I actually do want to think of the pi over 12s as well, because to get pi over 4, right, pi over 4 is going to be 3 pi over 12. So pi over 4 is actually going to end up like right here, and then any other multiple that has that's a fourth would be, so this is 2 pi over 4. So it takes 1, 2, 3 to get to pi over 4, and then another 3 to get to 2 pi over 4, which is pi over 2. And then 1, 2, 3 would be 3 pi over 4. And then another 3 would get you to 4 pi over 4, which is pi. And then 1, 2, 3 would be 5 pi over 4. And the pi over 4s are actually pretty important. If we talk about the key points of sine and cosine, we have 5. For tangent, we also have 5, but 2 of those aren't actually points at all because we're undefined. At those points, we actually have vertical asymptotes. So it's really 2 vertical asymptotes and then 3 key points that I'm worried about. Okay. So I'm going to continue going backwards here to label this. that up. That's why you shouldn't stop counting multiples of pi in the middle. And again, I am going to put in negative pi over 4, and I'm going to put in negative 3 pi over 4, and negative 5 pi over 4. Okay. So we saw that at pi over 2 and negative pi over 2, we had vertical asymptotes, is what actually happens here. It's undefined. And so what that means is we actually have a vertical asymptote. We have a non-zero number over a 0, which gives me a vertical asymptote on the graph. We talked about that earlier. Now I know that I normally wanted to take up as much of the graph as I wanted, and when I was doing sine and cosine, that meant that I would label this as 1 and down here as negative 1. But I'm actually going to go up by 1s here. So this is 1, this is 2, this is 3. And the reason I'm doing this is because otherwise the shape of tangent just doesn't look as good as it should when it gets too far stretched. And so here we are. We saw that 0, 0 was a point on the graph, and pi over 4 gave me 1, and negative pi over 4 gave me negative 1. And these are really the key points that I'm interested in graphing. There's also pi over 6. We found those values, so pi over 6 was negative root 3 over 3. I mean, I can put that in my calculator and see what root 3 over 3 is, but I don't have like an intuitive understanding of what, it's about 0.577, so that's a little bit more than a half. So it'd be like right here. And then pi over 3 is root 3, and root 3 is 1.7, okay? So that's 1.7 would be somewhere here, okay? And so the same thing, we'd have sort of the mirror image here, a little bit more than a half, and then 1.7 there. So I don't care if you have all of these points graphed. The points I'm concerned about are where it's equal to negative 1 and 1. But what happens is, as we get closer to pi over 2, we go closer and closer to negative infinity. So this comes up, goes through these key points, and then up towards infinity on this side. So this is what one cycle of tangent looks like. And then this just repeats. And so that's why I labeled my my over 4s here. So it's going to go negative 1, 0, 1. And that's going to repeat again, but we can't fit the vertical asymptote on this graph. And then over here we have our 1, 0, negative 1. And again, this will continue. And so it's not a complete straight shot between these 3 key points in the middle, but this is the important part of the graph, is it kind of levels out here. It almost looks like a straight line, and then it curves up towards infinity and down towards negative infinity. So that's how we graph tangent. This is y equals tangent of x. This is the most basic tangent function that you can have. Okay? So now we're going to go through this same process with cotangent.